All right. So first, oh no, what's going on? What's my pen going? Stop. No. Stop. Okay. So first, let's go over the homework, and then we'll take a look at some more examples today involving a little algebra. And then we're almost done. I think there's not much to talk about the sum and difference formula, just as long as you guys are aware of it. That is all that's really necessary. All right, so for homework, we had the cosine of 105. The first thing that I asked you to do was to find some sort of addition or subtraction of two more known angles that would give us 105 degrees. So I was just asking you to come up with either, some x plus y that gives us 105, or some x minus y that gives us 105. Now, honestly, there are a number of answers that you can choose from, right? And, if we weren't worried about picking nice angles, you could literally pick anything, right? 100 plus 5 degrees or 110 minus 5 degrees. But part of this is being able to calculate trig equations, trig functions, without the use of a calculator. So to do that, okay, like we talked about yesterday, we have to utilize the unit circle. I don't know what is going on. I don't want to be drawing all over the place. And I got rid of that. That's too much. Okay, anyway. So looking at some of these, right, I need a combination of some of these nicer angles that will give me 105. So you do have a few choices. I see that 45 and 60, if I add those together, okay, that can be one combination. All right. Let's see if I do 135 minus 30. That also gives me 105. And then I can even keep going and choosing some of the larger numbers like 210, 225, 240. But we like to keep things nice. Okay. My recommendation is if you can work within this first quadrant, if you can pick something in between 0 and 90 degrees, that is your best bet. Everything here is positive. It's your most simple quadrant. All right. So actually, I'll do both. So for your first answer, you could have had anything, right? These two are acceptable. 45 plus 60 or 135 minus 30. So actually, I'll do both of these and show you that we get the same thing. All right, so I'm just going to give us a little more room. I'm going to put these up top. Actually, I'm going to rewrite them. So I have the cosine of 45 plus 60, or the cosine of 135 minus 30. Okay, and like I said, I'll show you both. So the rule for cosine. So I'm going to write it like this. U plus or minus V is, I'm not going to have enough room up there.
Mr. Murray, before we continue, does it matter where we put the numbers? Like, what if I put cosine 60 plus 45? Does that matter or no?
For addition, no, it does not matter. You could have had the 60 first and the 45 here. For subtraction, it does, because if you did 30 minus 135, you'd get negative 105, which is slightly different. You might end up with similar numbers, but some of them might be negative instead of positive. So if you do the addition and subtraction here, that might mess you up. But good question. Yeah, if you chose the addition route, it doesn't matter the order.
Okay. All right, thank you.
You're welcome. So here what I did is I wrote the equation, but I wrote both instances in one equation. So it's kind of introducing a new sign. So this we call a plus minus, or yeah, plus minus sign. So here I flipped it and I have a minus plus sign. So this means that I can add or subtract, but this means that if I'm adding here, I'm going to be subtracting for this part. And if I'm subtracting here, then I'm going to be adding. So they match up like that. All right, so that's something that might be new for you, so don't get too confused by that. That's just saying, this is just saying do the opposite of what you see in here. So first, let's do the cosine of 45 plus 60. So that's going to be the cosine of 45 times the cosine of 60 minus the sine of 45 times the sine of 60. All right, so that's how your setup should have been. That's a 60. I gotta buy new markers. All right, so let's use our unit circle to evaluate this now. Let me see if I can make this a little tinier. And let's zoom in a little bit too, so, and that's not helping. Okay. All right, so the cosine of 45 is the x value of 45, which is root 2 over 2. The cosine of 60, which is the x value of 60, is 1/2. Minus the sine of 45, which is the same as the cosine, root 2 over 2, times the sine of 60, which now is root 3 over 2. And now we just simplify. So I get root 2 over 4 minus root 6 over 4. So root 2 minus root 6 over 4 is your answer. And if you notice, this looks very similar to what we had yesterday, all right, to the solutions. Using this method, a lot of your answers are going to have these numbers involved. A root 2, a root 6, and possibly a 4 in the denominator. It's just the behavior of what we do, okay? It's the behavior of the trigonometry with the unit circle. All right, so there, be careful again for the answers, right? Well, obviously, C wouldn't be the answer because that's addition. But here, again, the order matters because we are subtracting. So A wouldn't be right because the 6 comes first. So your answer would be B. Let's see if we get the same thing when we're doing here, because that's actually going to be a little interesting. So now I'm going to redo it as cosine of 135 minus 30 degrees. All right, hopefully I have enough room. So I have the cosine of 135 times the cosine of 30 plus the sine of 135 times the sine of 30. So here right away we kind of see, all right, well, that's an addition sign. And well, I know my answer has a minus sign, so let's see what happens. Well, this negative is going to come from the fact that when I deal with 135, the x value is negative. All right. I'm sorry, the y value is negative. No, the x value. Yeah, x value is negative. So that is going to change things. And that is why I said originally, if we can work in that first quadrant, work in the first quadrant, you don't have to worry about any sign changes. Okay, it keeps things simple. So the cosine of 135 is a negative root 2 over 2. So don't forget about that negative. The cosine of 30 is root 3 over 2. So if we see, when, before we do anything, multiplying these two together, I'm still going to get that negative root 6. So that looks like we're on the right path. The sine of 135 is positive root 2 over 2. And the sine of 30 is 1/2. So I get a similar answer. It is just in a different order. All right. So if you did it this way, okay, I skipped some steps in simplifying there, but it's the same as before. So I just put them all together just to save some space. Right. So if you're looking at this, right, this is what you calculated, and you go to a test or something, and these are the answers that you see. Well, you can tell yourself, all right, well, the root 2 is positive, so it's not going to be A, so it might be B or C, but I still have that negative in front of my root 6. All right, so that tells you that your answer is B. Right, and we can switch them. We can switch that numerator. So instead of having negative 6 plus 2, we have 2 minus 6. And again, like I said, you could have chose some larger numbers. Okay, you could have done, 3, whatever, I don't know, 330 minus whatever you need to get 105, okay? But again, you're dealing with more negative numbers, so that just leaves extra room for error, I think. If you like to do it that way, that's on you. But part of my job is making it as simple as possible. So try to stick in that first quadrant. All right, any questions about the homework? I knew that took a little long, but I just wanted to make sure we talked about all of our different parts. All right, so today, I lost my page. Yeah, we don't have much more to go with this. So we may be asked to simplify using our rules. All right, so this is how it is going to look. All right, we may be asked to simplify and kind of get rid of extra parts. So here I want to write the expression only in terms of theta. So I don't want to have anything extra. I just want some, cosine of theta, sine of theta, whatever it may be. All right, so we see the cosine. We see it's a sum or difference. We are subtracting. So I'm going to use the rule that we just did. All right, so I'm not going to write the whole thing out just because I want to save space. But I can rewrite this as the cosine of the first times the cosine of the second. Because this is minus and we're dealing with cosine, we're going to have plus. Okay, it's the opposite for cosine. And then we have sine of theta times the sine of 3 pi over 2. So this works nicely because I don't have to break down 3 pi over 2 anymore. 3 pi over 2 is 270 degrees. Okay, that is, oh no. All right, 3 pi over 2 is down here. So although I told you, normally you don't have to memorize the unit circle, I would try to memorize the not four corners because it's a circle and it doesn't have corners, but the 4 major axis points. So 0, 90 or pi over 2, 180 or pi, 270 or 3 pi over 2, right? It's a combinations of ones and zeros. Those are our most simple trig functions. So here, the cosine of 3 pi over 2 is just going to be 0. So this whole term goes away because it would just be cosine times 0, which is 0. Sine of 3 pi over 2, well, this is telling me that's going to be negative 1. So if this is negative 1, then we can say that the cosine of theta minus 3 pi over 2 is equal to negative sine of theta. And that's it. All right, so most of the time when you are given this situation, you'll be given nice things there. Okay, and actually we can use this to prove those co-function identities that we saw when we were dealing with identities. All right, so I'm going to do one of those to show you. Okay, so our co-function identity said that the sine of an angle minus pi over 2 gives us the cosine function. So let's break this up. So I'm going to have, so for this one, again, I'll write it just because we didn't see it before. And I'm using x, y instead of u and v. It doesn't matter. So for this, we swap. Okay, and our sign stays the same. If it's plus inside, it's plus out there. If it's minus, it stays minus. So this I can rewrite as the sine of x times the cosine of pi over 2 minus, and now I swap them. I wrote it a little differently here, but I'm going to write now, actually I'll do the sine of pi over 2 times the cosine of x. So again, pi over 2 is one of those nice angles. Okay, it's 90 degrees. The cosine of 90 degrees is 0. So this goes away. Did I do this right? Oh, no. The identity is negative cosine. I missed that. This gives us 1. So all of this is gone, and I'm just left with negative cosine. All right, so we just proved the identity. Okay, there's one other type of problem, but I don't know if we're going to have enough time. Yeah, I don't think I have enough time. All right, guys. All right. Any questions? All right, then I think we're going to wrap it up with the with the sum and difference formulas. There's not much more to go into it. There's one other type of problem, but I don't think we're going to see it too much in the future. If I think it's going to become a problem, we'll revisit the topic and we'll go over it if we need to. But I think we'll be okay. So yeah, all right, yeah, no homework tonight, and then tomorrow we're going to move on to a new topic called double angle formulas, multiple angle formulas. So we saw an example where we had to solve with one, but now we also have some relationships. And so just a heads up, over the next day or two, there's going to be a lot of formulas thrown at you. But then after that, we're done with knowing the different formulas. And, you know, not to be a naysayer, we don't use them too much outside of trigonometry. Even in calculus, it's good to know them, but unless you're dealing with very specific science where you need trigonometry a lot, you probably won't encounter them too often. All right, guys. So we'll meet back up tomorrow. We'll start our new topic, and we'll take it from there. Have a good day. I'll see y'all later.
Bye.